Hello everyone, this is Urja Pawar. I am a second year PhD student in Munster Technological University, Ireland, and prior to that I graduated as an engineer from India. So during my undergraduate I was very much involved with development based projects, web application or Android application, and in my third year I joined one startup in which my task was to filter ECG signals from SCG, PPG and ECG signals coming from a device and then detect arrhythmia uh, from those signals. So that was my entry point to the world of data science and AI. And after my undergraduate was completed, I joined Optum Global Solutions as a software engineer. And after that, I joined this PhD program, which is partly funded by McKesson Private Limited. McKesson is a healthcare-based company, and so the domain of my PhD is in explainable AI in healthcare. So it deals with explaining the predictions or classifications made by AI systems in the healthcare domain to clinicians and medical practitioners. I would like to join fellowship.ai program because in the coming summer months I will be mostly involved in self-study, and so I would like to deepen and strengthen my technical skills in the domain of AI and data science. And essentially I want to work with a good community, and I want to satisfy myself with an applied work in this space. So the challenge I picked was performing sentiment analysis on Twitter US airline database, in which we have information regarding what the tweets were, for which airline it was meant for, the retweet count, the location, etc. And I started my exploratory data analysis by first analyzing the distribution of different sentiments and different airlines. So I saw that the negative tweets were much more than positive and neutral, which is expected because we tend to review or tweet more when we have a bad experience. And then in the analyzing the distribution of airlines, there were too many tweets for United Airlines as compared to other airlines. Then there was this analysis of positive versus negative versus neutral tweets corresponding to different airlines, and in that we saw that negative tweets were much more in United Airlines as compared to the positive tweets for that same airline as compared to the Southwest Airlines, in which almost same number of positive and negative tweets were present. And after that I was interested in knowing what's the word length corresponding to different tweets corresponding to different sentiments. And so the word count for negative tweets were much more than the word count of positive and neutral tweets, because we tend to give more information about our bad experience as compared to a pleasant one. After that, I was interested in knowing what sort of words were used in negative versus positive versus neutral tweets, and that too for different airlines. And so we can see that words such as thank you, pleased, best experience, etc. were used in the positive tweets, as well as delayed, cancelled, words like this were used in the negative tweets. Corresponding to different airlines, we can see that gate and seat related issues were more common in United Airlines, because seat and gate were the more highlighted words as compared to delay and late words in Delta Airlines. This analysis can be actually useful for the airlines themselves, because then they can consistently see what sort of issues customers are facing, and then they can improvise by providing their customer service. So after the data analysis, I started with the pre-processing of the data set. Now, as I mentioned, there were too many negative tweets as compared to positive or neutral ones, which will make our model somewhat biased towards the negative classification as compared to the positive or neutral classification. So for eliminating this, we apply augmentation techniques. Now, there can be different types of augmentation techniques that can be used for this: oversampling, undersampling, or combination sampling. So in oversampling, what we do is we basically increase the number of samples or records corresponding to the minority class. In undersampling, we decrease the number of samples or records corresponding to the majority class. And in combination sampling, we use both, some oversampling and some undersampling, to balance the data set. Now, this is This dataset is not as simple as the image or categorical dataset. If it was an image, the augmentation can be done by flipping the pixels. If it's a categorical dataset, we can observe the distribution and we can apply mean, median or average techniques for augmenting the dataset. But since it's a text dataset and so it has a context, it has a domain, so for that it is very hard to come up with good augmentation techniques. And so as suggested in the challenge itself, we applied easy data augmentation technique, in which there were 4 approaches that were proposed: random swap, random insertion, random deletion and synonym replacement. So I used synonym replacement, in which it basically swaps a number of words in a sentence with their synonyms, and so this basically won't change the meaning of tweet. So it made sense for me to apply synonym replacement technique for augmenting this data set. And so it was oversampling of positive and neutral tweets, so that the number of records corresponding to the positive and neutral tweets becomes more and is comparable to the number of records corresponding to the negative tweets in the training input. Now when we want to train a classifier to classify text data, we want to make sure it's a good one, and for that it needs lots of data to train. In our current training set, the total number of records were approximately 20,000, and that was not too much. So in cases like these, we use transfer learning. In transfer learning, we basically use a base model that has been trained on lots of data, and then we gradually unfreeze layers from the end and train on our data so that it is customized according to our requirement, our classification purposes. And in this way, the knowledge that has been learned in the initial layers of the base model remains intact. So in this particular challenge, I have used a universal language model as suggested in the challenge description for the purpose of transfer learning, and then I basically started with first training a language model and then a classifier. Now a language model needs to be trained first because it captures the structure of the text information that is provided to it. And so I take the universal language model and then I unfreeze the last layer of that model, and then I feed my data into that model to learn the structural information of the tweets for the purpose of classification. And this particular language model is then fed to a text classifier, in which we gradually unfreeze layers from the end to see changes in performance metrics such as accuracy, precision, recall. Apart from the accuracy metric, which is total number of correct classifications made divided by total number of classifications, we have precision and recall. Now precision basically tells us how many specifically correct classifications were made out of the total classifications made for that class. So if my model is identifying n number of tweets as negative, and out of those n tweets only k tweets are actually negative, then I'll say my precision is k by n. And so some of the positive and neutral tweets are also considered negative by my model. Recall will tell us how much relevant classifications have been made by our model. So out of the actual m number of negative tweets, how many of those m negative tweets my model was able to classify as negative. So recall metric can be specifically useful by the airlines to actually run sentiment analysis and sentiment classification on all the tweets that were targeted to that airline, and identify all the negative tweets so that they can improve their customer service. Now if recall metric is low, then it will mean that out of the actual negative tweets existing in the data set, our model was only able to identify a handful of tweets as negative. The rest of them were considered positive by the model. So we want our recall metric to be high in that case. For modeling purposes, the train to test split that I used was 80-20, and so on the test data set, the accuracy my model was able to achieve was 77.2%. Now, for the negative classifications, the recall value was pretty good. It was 96%, but it was less than 50% for the positive and neutral classifications. This poor performance might have been improved if more advanced feature engineering and modeling techniques would have applied. Apart from that, things like lack of sufficient data, lack of proper structure in the tweets because the tweet length is fixed, then presence of sarcastic or humor content in tweets might have also affected the performance. Working on this challenge was a revisit for me to the domain of natural language processing, and I look forward to working on more AI applied projects in the fellowship program, and I am waiting to hear from you. Thank you.